Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called QQCC by Mello Robinson, and here are the rules. We need to divide the grid into regions so that every row, column, and region contains the digits 1 through 6 once each. So this is chaos construction rule set. The regions have to be orthogonally connected. Otherwise, it would be a very weird region. What does it mean to be orthogonally connected? It means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because to get from any cell in the region to any other cell in the region, you can just go through edges while staying within the region. This is an example of an invalid orthogonally connected region, because to get these two cells can get to each other by going through edges while staying within the region, but they can't get to the other cells in the region by going just through edges while staying within the region. They either have to go through a corner or exit the region by going through an edge, neither of which is allowed. And that is how chaos construction rule sets work. The digit in the top left cell of a region, that is its leftmost cell in its highest row, is its region number. And all region numbers are different. So in this region, this would be the region number because it's the leftmost cell of the topmost row, right? So we look at the topmost row, that's the top row, and therefore this is the leftmost cell of it. If this were the region, then this would have to be the region number because the topmost cell row is here and the leftmost cell is there. This is not considered the leftmost cell of the topmost row because it is in the middle row here. So that's how region numbers work. N is in a circle clue indicates that both region N and the digit N appear in the surrounding cells at least as many times as it is in the clue. Interesting. So N in a circle clue, these are quad clues, indicate that both region N and the digit N appear in the surrounding cells at least as many times as it is in the clue. Obviously, the region N only has to appear once. I think they mean that the digit N has to appear in the surrounding cells at least as many times as it is in the clue. So, for example, this must contain 1, 2, 3, and 6 as digits surrounding this quad circle, and the regions corresponding to the 1, 2, 3, and 6 also must appear in the surrounding cells. Interesting. This is saying 5, the region 5 must appear in this region, surrounding this quad circle, and 5 has to appear twice in the cells surrounding this quad circle. Interesting. Anyways, those are all the rules. If you like to play along, there's going to be a link in specifically the region N matches its region number, right? So keep that in mind. I'm not sure if that was very clear when I was saying that region N has to be there. But basically, this is saying region 1, the region with region number 1, region number 2, region number 3, and region number 6 all have to appear surrounding this circle in one of the cells surrounding this circle. And again, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Whoops. Okay, let's draw a border around the entire grid. And we know these belong to, oops. These belong to 4 separate regions. So this as a region has to go this way. So we'll make that orange. This has to go here. Orange has to continue on here to form a valid region, so pink has to go here. This has to go that way, so we'll make that blue. And we have 1, 2, 3, and 6 surrounding this. This has to continue that way, so that's orange. Don't know about these. This is likely to be the region number of its region. Actually, it has to be. Right? It can't go... It has to be able to form, like... This is a separate region, too. Yellow has to be a full region. So if we try to have blue come up higher than this, or even just level with this, it just can't, right? Because then yellow's going to be too small. And then otherwise blue's too big to make that, right? So if we try to have this go blue here, obviously, then yellow's just a 1-cell region, which is not possible. So this has to match its region number. Interesting. This orange is either going to be here or here. We are guaranteed, so this has to have a combination of 5 and 5, which means 5 cannot appear anywhere else in these 2 rows or these 2 columns. We have a guaranteed 2 and 3 here. We have a guaranteed 2 and 3 here, which means 2 and 3 cannot appear in the rest of row 2 and 3. We have a 1, 3 guaranteed here, which means 3 cannot appear in the rest of columns 2 and 3. So that means these digits have to be 1, 4, 5, and 6 as possibilities. We know this has to be a region number, but we don't know whose region number. It could be pink. That could certainly be the case. Blue can never get to here. Region number 5... has to be surrounding this. And we have 2 5s here. What does that mean? These digits have to be 1, 2, 3. No 3. 1, 2, 4, 5, 6. These digits cannot be 5, so it's 1, 2, 3, 4, and then 6. There's no way a 5, or there could be a 5 here. The region number cannot be 5 for this region. If this were region 2 or 3, how would it ever get to 2 or 3 here then? It can't get to here. So this cannot have a 2 or 3 there. It's 1 or 6. This would be interesting. So if the orange is part of this region to be 2 or 3, it would have to be region 2. So could this work is another question, right? So if we have orange go here, this is pink. Yellow has to go this way, which means blue has to go this way. One of these has to be region 5, so then this would be a separate region. Because this can't be 5. You can't get up that, can't go that way, because that would block pink. And blue can't reach there, obviously. So then blue would have to go here all the way around. Red would have to go here. This would be yellow. Pink would have to go around this way. So pink would have to continue here. Oops. Pink would have to continue there. Yellow would have to go here. Red could go down. And then the problem is, right, one has to be, the region 1 has to reach this region. But the region 1 has to also reach this region. Well, orange is not reaching it. Pink is not reaching it. Blue's not reaching it. So we only have 1 out of regions 1, 2, 3, and 6 reaching this region, which is impossible. So orange cannot go down here. That means orange has to go, well, we know this can't be 2 or 3. Orange has to go here. So this has to be not regions 2 or 3 because it's not entering here. Blue can't be reaching there. So therefore, this is regions 1 and 6. That means this is regions 2 and 3 here. This is not region 1, because if this were region 1, then... Hold up. The digits here can be 2 or 3. So this could be... Okay, so this is not... That's not valid. This can't be... Okay, so this is not region 1, because 1 doesn't reach here. It's not 2 or 3. So region 2 and 3 have to go have to have one surrounding cell around this area. Same with 1 and 3 here. So this cannot be 1, 2, or 3. It must be region 6. And this is the region number. So that's 6, which means this cannot be 6 in the region anymore. So this digit must be the same as that digit, which is region 1, 2, or 3. The only one it can reach then is this one. So this is pink. And this does not go through here. So this cannot be region 1. So this is region 2 or 3. This can't be region 6 anymore. And so this has to be 1, which eliminates 1 in the rest of the surrounding quad and row. This is region 2 or 3. It can't be 3 because 3 has to go around here. So then this must be region 2. So that means 2 no longer is available in the rest of this region. So where's 2 in row 2? It has to be here. So this is 2. This is no longer 2. This is region 1. It has to get to here. So therefore this is blue here. There's only 1, 5 available. That doesn't work. How? That's not going to work. Because we can't have multiple 5s here. We have to have a 5 here, but then that's supposed to be part of region 5. Oh. Well, it can't go that way then. If we tried going that way, it's not going to work. So that means it has to go this way. So if we tried making this a different cell, it has to go this way to connect. But that's not going to work because, again, we don't have the 5 as the 5 region entering this because we have to have the 5 there. So this is blue, which means yellow has to go that way. So this is done as a region. This is a boundary. That means whichever 5 is here is... So let's make this actually yellow. We have to have a 5 here as a region border or as a region number. And we'll make this green, I guess. This is so we have region 6 here and region 2. So region 3 has to enter here. Region 1 has to enter here. That means we have a guaranteed 5 here. This is going to be part of its own region. And it could be part of this. We don't know. We don't know about this either. So we know these two have to be part of... Well, actually, yes, it does have to go down. So this 5 has to be the region number for it. And it cannot be here, obviously, so it's one of these two, which means you cannot get any more left from this cell. So this has to be at least these. And we have a 5 guaranteed here, so this cannot be 5 here. One is here. 2 has to be one of these two. Okay. This is region number 2 going through. We have region number 3 having to go through. So this is region number 1. This has to be region number 3. So this cannot be 3 here because that would not be the region number. So this has to be 6 and this is 3 here, which eliminates 3 in the rest of the row. So this is 1, 4, 5, 6. Then in the remaining pink rows, this can't be 6. We are guaranteed then this is a 2, 3 pair. So this is 6, which eliminates 6 in the rest of the row. Green definitely has to be one of these two to have the 3 as a region number. And it cannot go around this way because then this would not be part of a region. So we have to have that as green. That means this is a region number of a region here. So it cannot be green because this is going to be the leftmost of some region. And it's not going to be blue, it's not going to be yellow, it's not going to be green, so it's a different region. So this is red. We could technically go down, but this can't reach. These cannot be reached by other cells. If we try to go 6 here, then that blocks red off, which is not possible. So red has to go down. This can't be 1, 2, 3, 4, 5, 6. Can't be reached by green. Can't be reached by yellow. Can't be reached by blue. So this is red. Same with this. This is red. So we have 1, 2, 3. One of these is 2 or 3. So 2 away from here can all be red. So these could all be red. We have one more here potentially being blue, or this is blue. Yellow has to go this way. Sorry, no, it doesn't. It could go to any of these. Green can go 3 away from here. So any of these technically could be green. This could be yellow. It can't reach here, though, because it's 1, 2, 3, 4, 5, 6, 7. So no yellow here. We are guaranteed this is all blue. This is a boundary. One of these is 3. We're not sure which. Yellow does have to reach here. If this is 1, 2, 3, 4, 5, 6 yellow, the problem is green is going to be stopped here. So this cannot be yellow. Cannot be yellow. So yellow has to go to one of these. 1, 2, 3, 4, 5, 6. Can it be 1, 2, 3, 4, 5, 6? Possibly. Because green could go something like that. No, if green goes all the way here, then the red is only that. So if we had yellow going here, green would have to go here, red would go here, and then blue would have to go up here, and therefore this wouldn't be the actual valid region number. So yellow cannot reach here. That means we have to get to, yellow has to get to here. So this must be yellow here. And it must connect this way, so that's yellow. And then one of these two, we're not sure which. So these are definitely yellow here, which means one cannot be either of those digits. We know this is definitely a boundary here, boundary here, boundary here. Green has to go 1, 2, 3. It could be 1, 2, 3, 4, 5, 6. That's possible. Or 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. It cannot go 1, 2, 3, 4, 5, 6 there too. Okay, this can't be 2 because of 2 in the region. Remaining digits of this region are 1, 3, 4, 5. This can't be 3 because of 3 in the column. These can't be 5 because we're guaranteed 2 5s here. So 5 has to be one of these two. Okay. 2 eliminates 2 as a possibility here. So red needs access to a 2, but we don't know where it is. Remaining digits of the yellow region are 2 through 6. No 3 or 6 here because of 3 or 6 in the column. No 2 here because of 2 in the column. 1 eliminates 1 from being there. The remaining digits of column 6 are 3 through 6. This cannot be 5 here. So where's 5 in row 6? It must be one of these two digits because the 5 has to be the region number here. So this we have region 2, so in this we definitely have region 3 in it. This we have region 6, region 1. Region 5 is here. Region 1 is here. Region 3 is one of these three. The red definitely has a 3 in it. So where is... That means this cannot be 3 here, even if it's red or green, because red already has a 3 in it in one of these 3 cells. Can't be here. Green has to have 3 as the region number, so it's one of these 2 cells. So neither of these can be 3, which means where is the 3 in column 2? It must be here. So this is 3, that's 2. This must not be red. So this is green. We have 4 greens here. You cannot go green, green here because then this red only has 5 cells in its region. So this can't be green, it's red. Which means red has to be one of these two. This can't be red, that's green there. No 2 or 3 here. 3 cannot be any of these cells here, which means we need a 3 in one of these two. So that's boundary. So one of these two is boundary. No 6 here because of 6 in the box. Or 6 in the region. Okay, so this has to be not region 5, because region 5 has to be touched in one of the cells surrounding here. So this is region 4, which makes that 5. No 4 in the remaining digits in the red region. 5 eliminates 5 here. So where's 5 in the orange region? It's here, so that's 5, which eliminates 5 there. We need 5 in the red region, which could be either of these, so that's fine. We need 2 in the red region, which we're guaranteed here. So this is 2, 3, 5, 6. It has to be 1, 4 as a pair in the green region, which eliminates 1, 4 in the rest of the row here, because we have to have 1, 4 for the green here. So this can't be 1, this can't be 4, this can't be 4. Hmm. 2 eliminates 2 from being here, and 2 from being here. Remaining digits of column 5 are 1, 2, 4, 5. Remaining digits of column 1 are 1, 3, 5, 6. We have a guaranteed 5 in red, but that's not helpful. Remaining digits of column 4 are 1, 2, 3, 4, and 6. This can't be 5, though, because one of these two is guaranteed to be a 5. Sorry, two out of these 4 cells are guaranteed to be a 5. Hmm. Actually, I think this is required. Yeah, if we read the rule set again, it is region N also has to appear twice, at least that many times in the clue. So then this has to be both blue. Which means this is not green. That has to be yellow. This can't be red. This can't be blue. So then we have those regions. I'm pretty sure, yeah, reading that again, that rule set, it's basically this does have to appear. The region also has to appear twice around this. Yeah, that makes the most sense. Otherwise, I think it's actually stuck as a puzzle. So therefore, this is a 5, because that's the region number. And therefore, this is 2. No 2 here, no 5 here. We have to have a 5 surrounding here, so that's 5. No 2, this is 1, 4 as a pair. That means this can't be 1, 4, it's 3 and 6. No 2 here because of 2 in the box, or region. 4 can't be here because of 4 in the region. This is 1, 4 as a pair. We have to have 3 surrounding this. So this must be 3 here, which makes this 6, which makes that 4. 3 eliminates 3 here, and 3 here. 4 eliminates 4 here, so that's 6, which makes this 1, which makes that 2. 6 eliminates 6 here, so it's 3 and 4. There's no more 6s here because and this is a 1, 4 pair, which eliminates 1 and 4 in the rest of the row. This can't be 1 or 4, it's 3. This can't be 1, 2, 3, or 4, it's 2. We celebrate the 3 in the corner because we're close to solving it. 3 eliminates 3 here. So it's 4, which makes that 1, which makes that 3. 4 and 6 eliminate 4 and 6 here, so it's 1. So no 1 here. 1 and 4 as a pair, eliminate 1 and 4 in the rest of the column. So this can't be 4, it's 6, which makes this 5, which makes that 4, which makes that 1 and 4. That makes this 1 and 4 here. This can't be 6, so that's 5, which makes that 6. And therefore, that's a 3. Apologies for that. I didn't basically specify out the region N. Or actually, I misinterpreted that. So that was on me for just misinterpreting that. I think it is clear, actually, that the region N has to appear in the surrounding cells also as many times as it is in the clue. So it has to appear twice. I did not understand that. But I understood it after trying to solve this because I'm like, how do we differentiate this? And I'm like, we can't unless we have to appear twice for region 5 surrounding this quad. Anyways, that's very cool. It's a very, very cool thought exercise with the region numbers and where they can go. Hopefully you weren't Well, if you tried solving this on your own and were confused about why, I'll try to make it clear in the description that the region, the n in a circle that means the region must appear that many times in the surrounding the clue. I think I misinterpreted that in when I was first describing the rules, and I think that is very valuable to solving this. Otherwise, I don't think it is solvable otherwise. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.